Hello and welcome to this practice session for CET exam. Today we will be talking about one chapter in physics. This happens to be a very important chapter as we will soon see. Let us start the exam preparation. Today's chapter will be electric charges and fields. This table gives you the list of all the important topics in physics as far as Karnataka CET is concerned. You will see that electric charges and fields appears at the top of the list. It is one of the most important topics in physics. Over the last few years, when you analyze the question papers of CET, you will see that these chapters have had higher number of questions. So electric charges and fields and wave optics have as many as 8% of the questions coming from those chapters. And the remaining chapters have been listed here as well. So these 11 chapters account for almost 70% of the questions in physics CET. So today we will be doing electric charges and fields. So we have a short practice paper. I will take you through the questions and the answers to each one of them. Towards the end, we will summarize the important concepts that have been used as part of these questions. So let's start the practice paper right away. The important concepts that we will cover as part of this is Coulomb's law of electrostatic forces, the concept of electric field, the principle of superposition of forces, the torque exerted on an electric dipole when it is placed in an electric field, the concept of electric flux, and Gauss's theorem. So these are the concepts that we will be studying as part of this chapter. Let's start right away with the questions. A charge Q is divided into two parts and the two parts are kept apart in air. The force between them is maximum if the two parts have the charge. There are four options. Now you've taken one charge Q and you've split it up into two charges and you keep them apart in air. Now in which of these situations will the force between them be the maximum? So let's take a look at how we can solve it. Remember, Coulomb's law tells us that the force is directly proportional to Q1, Q2 by R squared, where R happens to be the distance. Now, in this particular example, the distance between them is fixed. We are not changing R. We are changing the two charges. Let us see what happens in each case. In the first one, F is directly proportional to Q squared by 4. Why? Q by 2 in the first charge, Q by 2 in the second charge. In the second situation, it will be 4. Force is directly proportional to 4Q squared by 25. In the third instance, the force is directly proportional to 3Q squared by 16. And in the fourth case, it is force is directly proportional to 2Q squared by 9. Now, if you compare these four fractions and see which one has the highest value, it is quite clear that Q squared by 4 has the highest value of the four fractions. So the answer to our question is when the charge Q has been split up into two charges of Q by 2 and Q by 2, then the force between them is the highest. So the answer to the first question is option 1. Two particles A and B are kept 2 meters apart in free space. Particle A has charge 2Q and the particle B has charge Q. The ratio of electrostatic force exerted on A by B to that exerted on B by A. So in this question, we are comparing two forces. The force exerted by A on B and the force exerted by B on A. And the question is about the ratio of these two forces. So let's start with the familiar equation, Coulomb's law. The force between the two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance. Now, the first charge is 2q and the second charge is q, and they are kept 2 meters. So the force is proportional to 2q into q by 4. And this is a direct application of Coulomb's law. Now, this formula is the same regardless of whether you're calculating the force exerted by A on B or whether it is the force exerted by B on A. They are equal. The force exerted by charge A on B is the same as the force exerted by the charge B on A. They are equal and opposite. And this is also in keeping with Newton's third law. So the answer to this question is 1:1. The two forces are equal in magnitude. That is the answer to the second question. So let's go to the third question. Two identical charges kept 2 meters apart in vacuum exert forces of magnitude 36 into 10 to the power of minus 9 newtons on each other. What is the charge? The charge of each of them is what we have to calculate. So let's start with our familiar Coulomb's law. We don't know what Q is. Q1 and Q2 are identical. Therefore, in our particular situation, force is equal to Q square by R square. And the proportionality constant is 1 because they're kept in vacuum. So by substituting the values, 36 into 10 to the power of minus 9 newtons is equal to Q square. And the permittivity in vacuum is 9 into 10 to the power of plus 9 is equal to So you can see that with a little bit of simplification, you get Q square is equal to 16 into 10 to the power of minus 18. So Q is equal to and so the answer is option 3. Now, for a quick explanation, this is Coulomb's law. It says that force is directly proportional to the product of the two charges and inversely proportional to the square of the distance. So what is K? K is a constant which you can call the constant of proportionality, or specifically it brings in the element of permittivity. So the permittivity in vacuum K happens to be 9 into 10 to the power of plus 9. So that constant is what we have to use when these charges are kept in vacuum. The answer is 4 into 10 to the power of minus 9 coulombs. Next question. 2 point charges Q1 and Q2 are placed on the x-axis. Q1 is placed at a distance x equal to d and Q2 is placed at x is equal to 2d. If the net force acting on a charge Q placed at x equal to 0, the origin, is 0, then Q1 is related to Q2 in what way? That's the question. So it helps sometimes to draw a diagram. So we have Q1 at a distance of d and we have Q2 at a distance of 2d. And here at the origin, we place a third charge Q. And the question says that Q1 is exerting a force on Q, Q2 is also exerting a force on Q, but the net force on Q is 0. So Q1 is exerting a force, Q2 is exerting a force, but those two forces are equal and opposite, so that the net force is 0. And that's what we have to calculate. The relationship between Q1 and Q2. So let us say that the force exerted by Q1 on Q is the force exerted by Q2 on Q is, now these two are equal and opposite. So we say Q1 Q by D square is equal to minus Q2 Q by 4D square. So Q gets cancelled, D square gets cancelled. So we will end up with a relationship Q1 is equal to Q2 by 4. This gives us the relationship between charge Q1 and charge Q2. And in this situation, the net force acting on charge Q at the origin is 0. This is the right option. Next question is, a glass rod when rubbed with silk acquires positive charge because positive charge can only be acquired if electrons are removed from it. If the number of protons and electrons are the same, then the object has net 0 charge. But in this case, since the glass rod has acquired a positive charge, it can only be because electrons have been removed from it. Option 2. 2-point charges are kept distance d in air. They exert a force of F on each other. The distance d dash at which they exert the same force when they are placed in a medium of dielectric constant K is, and there are 4 options. So let us understand what this question is saying. There are 2 charges, and you can call them Q1 and Q2. They are at a distance of d, right, in air. So the force is proportional to Q1, Q2 by d square. But when the same 2 charges are kept in a different medium, they are kept at a different distance, and the distance is d dash, right? And there is a dielectric medium, and the constant is K. And in this case, the force becomes Q1, Q2 by K d square. The force has reduced. So these 2 forces are equal. So when you equate these 2, you will get Q1, Q2 by d square is equal to Q1, Q2 by K d square. So these go in these, I'm sorry, this is not d square, but this is d prime square, because the distance has changed. So you cannot cancel d square here, there is d square here. So this will lead us to a relationship between d dash and d. By simplifying this, you will say d dash is equal to d by root k. And that is our answer. This one, option 2, is the answer for this question. So what happens is, first the charges Q1 and Q2 were in air, and they were at a distance of d from each other. Later on, they were moved to a different medium where the constant, dielectric constant, was k. But to exert the same force on each other, they are now at a distance of d dash. So what is the relationship between d and d dash? That is the question. By equating the 2 forces and eliminating Q1, Q2, you can get the relationship between d and d dash. And that is option number 2. Next question is, a charge enters a region of uniform electric field with its initial velocity perpendicular to the direction of the field. The trajectory of the charged particle in this electric field is. Now, let us draw this situation. Let us say that there is an electric field, uniform electric field, remember? And this is E. And we have a charged particle which is entering this uniform electric field with a certain velocity, and that velocity is perpendicular to the electric field. So we can say it enters it with a velocity v, which is perpendicular to the electric field. Now this will begin to move like this. The horizontal velocity will not change because there is no force acting on it in the horizontal direction. Its vertical velocity will change because of the electric field. So it will move in that direction. Now this is very similar to another situation. You can imagine that there is a gravitational force, a gravitational field that exists all around Earth. And if you throw a ball in the horizontal direction, in what direction will it travel? It will travel in this trajectory. We say it is a parabola, right? So it is a very similar situation. So the answer to this question is parabola. The next question is, a gold leaf electroscope is used for which purpose? Well, the gold leaf electroscope is used for two purposes. It is not only to detect the presence of electric charge, it is also to determine the magnitude and the nature of the charge. So of the four options, option 4 is the correct one. And that describes the manner in which a gold leaf electroscope is used. The 10th question. A charge supplied to a conductor resides where? So when a conductor is supplied a certain charge, where do the charges reside? That's the question. When a charge is supplied to a conductor, it is always on the surface of the conductor that the charge resides. So it is not uniformly distributed in the entire body of the conductor. It only resides on the surface. So option 2 is the correct answer. So we have come to the end of a few practice questions. And what I want to do is summarize for you some of the important concepts that we used as part of this practice session. So let us discuss these important concepts that we used as part of today's test. The first one was Coulomb's law. This is about the force between two charges which are placed near each other. And the force is directly proportional to the product of the charges and inversely proportional to the distance between the two. And if you want to bring in a constant and make it into an equation, and the constant k happens to be equal to 1 by 4 pi. This is called permittivity. This is permittivity. And in SI unit, it is equal to 9 into 10 to the power of 9. So this is Coulomb's law. It depends on the two charges and the distance between them. As the distance increases, the force decreases. This is Coulomb's law. This was one equation that we used repeatedly in today's paper. What else did we use? We used the concept of electric field. Now, what is electric field? Electric field indicates the force exerted by the field on a unit positive charge in the field. The electric field shows both the magnitude and the direction of the force exerted by the field on a unit positive charge. Now, therefore, E is equal to the force divided by the charge. If a charge of Q coulombs experiences a force F, then the electric field at that point is given by E is equal to F by Q. And the units of E, Newton by Coulomb, because this is force by Coulomb, charge. The next thing we studied was about, or the next principle that we used was the principle of superposition of forces. What does that mean? Superposition of forces basically means that if you have a charge Q plus Q1 here, what is the electric field around it? The electric field around it is going off in all directions away from the field, away from the charge. If I have another charge Q2 here, which is plus, then again the electric field moves off in all directions from the charge, and so on. Now if I pick any point here, and we'll do it with a different color, then if I put any charge Q here, then the charge Q1 exerts a force in that direction on Q, and the charge Q2 exerts a force in that direction on Q. So what is the net force on Q is given by a vector addition of the two individual forces. So you can add this force and get the resultant force, and that will tell you the resultant force exerted by Q1 and Q2 on the charge Q. And this is called the principle of superposition of forces. So the resultant force, resultant force at a point is the vector sum of all the forces at that point due to the different charges, and that is the principle. Okay, so these were some of the important concepts that we used as part of our questions today. In the next class, we will talk about more questions from the same chapter, and we will cover the concepts of electric potential, electric flux, and Gauss's theorem. Thank you.